Hey everybody, this is Pete, and in this video I want to answer a question that was posed from a previous video about how to control the assembly pattern when you're creating a multi-body part. So what happens is sometimes we create a multi-body part to represent an assembly. We can use it as a factory asset. There's all sorts of reasons why we would model an assembly, quote unquote, inside of a part model for simplicity's sake or for top-down design. But what happens is sometimes when we create these designs, we end up creating like a solid that represents the final design but isn't as useful for individual parts. So for example, if I was to port this in as an assembly, so I'd go ahead and do the manage, make components, grab these two. I'll just accept all the fun stuff, hit next. Yep, so I'm just gonna not do anything. What happens is when I get to the bill of materials, there's only one threaded stud, right? So instead of it being a bunch of different things, there's only one of them. Now, granted, I could hit save here, but the point is that instead of saying there's 12 or 10 or how many ever you have, it just puts it all as one. So what I want to do is I want to give you a couple of options. So the first option that I'm going to take on is how do I do this if I have a regular pattern like this, circular pattern, rectangular pattern, etc., etc. How do we handle that? And then I'm going to make another video, which I'll link below, where we're going to handle something more like an irregular pattern. So we'll touch on that in the next video. So a couple of things I would recommend. If you're going to do this method, you need to come up to the parameters, and I would definitely make your parameters. So I've got row spacing, row count, column spacing, column count. So I've made all those ahead of time. I've already created the pattern. So to do this, I'm going to go ahead and in the Manage tab, I'm going to make a part. So I'm going to do this the weird way first, and then I'm going to show you how you can control this. So I want to grab the threaded stud. I'm going to call it threaded stud, and I want to save it to this location. So I'll just double check and make sure there's nothing in there already. Perfect, so that's a good location. And then we'll go ahead, I don't want to make the assembly yet. We'll go ahead and hit OK. So here's what you get. So it grabs exactly the solid. This is what we saw when we just built the assembly. And but it's linked. Here's the important bit. It's linked back to this model. So here's what we're going to do to make this work. I still want to represent this, but I'm going to make some quick changes. I'm going to suppress this feature, and I'm also going to suppress the threading. Okay, and the reason I suppress the threading is because if I come back to my threaded stud, it's going to look at this and see that there's an update, and there it is. It goes back to being the way it was. The problem that I have with if you put features into the solid body before you send it out as a make part or make component and create a new part from the solid, it doesn't really grab the feature data. So I'm actually going to apply the threading back in here. Now it remembers the last setting, otherwise you would have to come in here and make adjustments, of course. That's okay. Because I want that threading to come through on the actual part. But I still want to represent this as the assembly. So here's one of the critical bits. I'm going to right click on the assembly. This is the derived part that comes with it, and I want to suppress the link. I could break it, but if I break the link, I can never reestablish it. So if there is a design change that I want to capture, I would be kind of out of luck. So that's why I'm going to use the suppress. And then we'll come back to this assembly part, unsuppress this one, and we can unsuppress that one. So now we're back to having the assembly, but our threaded stud remains exactly like we want it because there's no there's no link back to the original. Right now we've suppressed that. So make sure you save it. That's another critical thing, making sure that that actually is created. So to save a little time, I've already placed the base plate, or I created that. So I'm just going to knock out a new assembly. And in this new assembly, I'm going to place those two parts. So here's that pattern plate, and I'm going to grab my threaded stud. Go ahead and place those. Now, because I used the make part, this automatically showed up in the right spot, which is totally cool. But if we wanted to constrain it, this is where we're going to do the next part. So the next bit is if we hit the F sub X, we want to be able to link back to the original so that we can grab those pattern constraints. So this is where you could use a simple link. And instead of looking for an Excel file, if it shows up as Excel, just switch it to Inventor part. And now I can go back to my base model. Hit open, and you'll see that there are a bunch of parameters. Now I also created some controlling parameters that located this in the original part model. If you wanted to constrain it, you could do that. I'm not going to take the time to do that, but I am going to grab these pattern parameters. If you get this, that just means I didn't set it to export in the part model, and hitting OK will make that work just fine. So go ahead and hit OK. Now we've got a live link back to that part model. So I hit done here, and we can simply create a pattern. So this is a rectangular pattern. There's our part, column, and then this is where I would grab my column parameters. So list it, there's a column count, there's my spacing, list. You can see I've done this before, so there's all my parameters. Then I can go grab the row, same deal, but we're going to flip it, and then I'm going to grab the row count and the row spacing parameters. Okay, so we're all set. So you hit OK. Cool part. Now when we take a look at this, it actually counts them correctly. So instead of just assuming all those studs were part of the same solid, now we get the individual count we're looking for. Bonus, this is tied back to the original. So if I come in here and I start making changes to it, so let's say we come down here and we actually want 7 columns. Puts it off the part. So then we have to play with the spacing. There we go. So we play with the spacing, we adjust that, hit done, go back to this assembly, and you'll see that it should request an update, which it did. Grabs those parameters, and it adjusts the pattern so that we now have an accurate count. So that's one way that you could still achieve your part model being like the driver of the design, or you could represent the entire design as that part, but yet still use that to help control the final design where you actually want accurate bill of materials counts. So hopefully you found that useful. I'm going to tackle a more complex pattern in the next video, but if you have any questions or comments, please let me know, and have a blessed day.